So first question we're going to take a look at is from 7-6 on solving an equation. And this is an equation where the first couple steps have already been done for you because we always have to get it factored, but this one already is. Once we factor it, what do you set each factor equal to?
Can you say that again?
So once it's factored, what do you set each factor equal to when you want to solve it?
This is 7.6, right?
Yes.
Yep, okay, 7.6. Set them both equal to 0?
Yep, so we're going to set them both equal to 0. So we'll start with cosine x plus 0.8 equals 0, and cosine x minus 0.5 equals 0. All right, so now we're trying to solve for x, but the first thing we have to do is get the 0.8 on the other side. How would you move that over to the right side?
Subtract?
Yep, subtract it. We get that. Now we're just trying to get the x by itself. So how would we get rid of cosine?
We do. Oh, we do the not opposite. That'll do the inverse.
Inverse. Yep. So we'll take inverse cosine on each side, and that's going to give us the inverse cosine of negative 0.8. All right. Now, is negative 0.8 a number that comes up when we do the unit circle?
Oh, when we do the unit circle?
Yeah, for any of the coordinates?
No.
No. So because that's not on the unit circle, you are not going to get a nice answer.
Okay.
So because I'm generally going to ask for the answers in radians, since that doesn't come out nice either way, we might as well put our calculator in radians right away.
Otherwise, we do degrees then radians.
Yes.
Okay.
So let's put it in radians. And let's do the inverse cosine of negative 0.8. All right. I'm sorry. We had it right. That's radians. So we get we'll say 2.498. Okay, so that's one answer. Now, that's not a nice answer, so it is not in a quadrant. So now we have to use this chart to figure out where our second answer is going to be. Okay, in radians, it's a little trickier because it's all decimals, but that's 0, pi over 2, pi, and 3 pi over 2. So, 3 pi over 2, which is 4.71. Okay, what quadrant would 2.498 be in?
S?
Yes. So we just found an answer in quadrant 2. There's another quadrant that we're also looking for an answer in. What other quadrant is cosine equal to a negative number?
T?
T, yep. Okay. What's the formula for quadrant 3, which is where the T is?
180 plus the reference?
All right, so if we were doing degrees, it would be 180 plus the reference. What's 180 the same as in radians?
180 is the same as pi?
Pi, yep. So the formula we need is pi plus the reference angle. That's the other answer. Okay. Right now, we do not have a reference angle. You told me earlier that that's in quadrant 2. A reference angle would always be in quadrant 1. So now we have to use this to figure out our reference angle. Then we can figure out our answer. So there's a couple steps to this. What's the formula in quadrant 2 to find your answer?
180 minus reference.
And then in radians it would be?
Oh, it would be pi minus reference.
Okay. So pi minus your reference angle will give you your answer.
Okay.
That is the answer. So let's fill that in right there. and see if we can work backwards and figure out the reference angle.
Okay.
So pi minus the reference angle comes out to 2.498. All right. What would we do next to try to get the reference angle by itself?
We would put pi on the other side.
Yep, and how would you move the pi over?
Subtract pi.
Yep, so 2.498, that's minus pi. That gives me negative 0.644. And that's the negative of my reference angle. So then what would be the positive of my reference angle?
0.644.
Yep, perfect, 0.644. All right, now we got our reference angle. We can fill that in and get the answer we want in quadrant 3.
Yeah.
So our reference angle is pi plus 0.644. So pi plus,
Could I have your attention?
okay, so pi plus 0.644. So our other answer is 3.786. And that's the two answers we get when we do the inverse cosine of negative 0.8.
Okay, so the answer would be 2.498, and then the 3.786.
For the left part, yep.
For the left part, and we went to the right part.
Yep. Now the right part, that's going to be that one's going to be a lot easier. What do we have to do first to get cosine by itself there?
We have to add 0.5 to the side.
Yep. So add the 0.5. And now, how would we get the x by itself?
We do the inverse.
Yep. Inverse
Inverse cosine.
Inverse cosine. Okay. Is 0.5 a number that comes up when we do unit circle trick?
No.
Think about when you're doing the coordinates for like the 30, 60, 90 right triangle. Do you remember what's the coordinate? Like if you're working with a 30-degree angle, do you remember what the coordinate is for the 30? The long side and the short side?
Not off the top of my head. What section is that?
I think we did the unit circle in 6.2.
6.2. Give me a second. 6.3. I haven't written it down, so I'll probably just look at it real quick.
All right, so now we figured out that 0.5 is a number that would come up when we are dealing with the unit circle. So that means we want to do this in degrees first and then convert to radians by hand because we are going to get a nice answer.
Okay.
So let's make sure we're in degrees first and type in inverse cosine of 0.5. That's going to give us 60 degrees. Okay. And that is a reference angle because it's in quadrant 1. Now we're looking for where cosine, and I'll convert that to radians in a second, but we're looking for where cosine is positive. What other quadrant is cosine positive in?
It is positive. Would that be S?
That's where sine is positive.
Cosine. C?
C, yep. And what's your formula in quadrant 4?
360 minus reference.
Okay, so 360 minus the reference angle, which in this case, 360 minus 60 is
300.
300. All right. So we got our nice answers in degrees. Now we're going to just change into radians. What's 60 degrees in radians?
60 degrees in radians is. Give me a second. Probably just on my phone.
And remember, we need an exact answer, no decimals.
Okay.
Well, how do you change from degrees to radians?
You do 180, 180 minus.
Nope, something with multiplication.
Multiplication.
You multiply by pi
You multiply by pi.
and divide by 180. So when you do that out, 60 goes into itself once, 60 goes into 180 3 times. So you get pi over 3.
Let me write that down. Thank you.
So now if 60 is pi over 3, how much would 300 be?
300 radians.
Yes.
So 300 pi divided by 180. So 300 goes into itself one time, and then, but it wouldn't go to 180. Oh, wait a minute. We can just do it because 60 times 5 would be 300. So
Yes.
we just do 5 pi over 3.
Yep, exactly. 5 pi over 3. Okay, so there's all our answers to that problem. The 2 decimal answers
Mhm.
and the 2 exact answers. There's no way to write the 2 on the left as an exact answer, so I would not ask you to do that.
Okay. Could you tell me again how to convert 60 degrees into radians?
Multiply by pi and divide by 180. All right, so let's take a look at the second one. So in this one, the first thing that we want to do is get it set up like this equation we had over for our first example. So our first equation was equal to what number to start?
0.
0. So let's get this one equal to 0 as well. Right. How could we get this equal to 0?
By putting everything on one side.
Okay, how would you do that?
You would put the 1 plus cosine over to the left.
Okay, we could put the 1 plus cosine on the left, and then what would you do? Like, I need some steps. How do I move it to the left?
We subtract it.
Yep. So we can subtract 1 from both sides and subtract cosine. And when you do that, what would you have on the left-hand side?
2 sine 2x minus 1. No, sorry. Plus 1 minus cosine x.
So what's that first one again? 2
2 sine squared.
squared. Yep.
Sorry. Squared x.
And then what was the rest?
Minus 1.
Okay, I'm going to put that at the end.
Okay. And it would be cosine minus cosine minus 1.
Minus cosine x minus 1.
Okay.
All right. Now that follows kind of a pattern of a quadratic equation, but the problem is we have 2 different trig functions. So whenever you have 2 different trig functions, I mentioned in class, you always substitute for one of them.
The one with that's squared.
Yes. So we're going to substitute for the one that's squared, and we have an identity that involves sine squared. Do you remember what that identity is?
For sine squared.
Mm-hmm.
Oh, 1 minus no.
Yeah, so 1 minus cosine squared x. We can substitute that in. Now, once we do that out, we're still going to have something squared and something not, but it's all cosines.
Okay.
So that's good. Okay, what do we have to do next on the left-hand side?
We can factor.
Well, it's hope maybe we can factor. We don't know yet because we still have to deal with this 2 in front of the parentheses.
Oh, so do we distribute them?
Yep. So if you distribute that, What's 2 times negative cosine squared?
Negative 2 cosine squared.
Okay. And then we're still going to have the minus cosine x. And then we have a minus 1. And we're going to get 2 times 1 is how much?
2.
So what's 2 minus 1?
1.
1. All right. Now we can try to factor it and see what happens. If it doesn't factor, what's the other way that you can solve a quadratic type of equation besides factoring?
Make it equal to 0.
Well, making it equal to 0 is what you have to do whether you're going to use factoring or this other method. But there's another method to solve quadratic equations.
We went over in the notes, right?
Yep, it's more of something from like, it's more like algebra, like an algebra 1 thing.
Quadratic formula?
Yes, you use quadratic formula. So if we can't factor it, then we're going to have to use quadratic formula.
Okay.
All right. What would be my first term in each set of parentheses if I'm going to try to factor that?
First term, it would be cosine
Cosine,
squared. No, cosine x.
yeah, cosine x. And what about my other one?
Also cosine x? Or negative 2 cosine?
Right, so that's going to be a little bit of a problem because of the side that we put everything on, we made the cosine squared negative, right? We can factor it like that. It is going to be a little more confusing. So my suggestion would be, how could we get rid of this negative? I don't care if anything else is negative. I really just don't want a negative right there.
So times everything by negative 1?
Yeah, so let's just change the sign of everything. We're still off to factoring it the right way. That's still going to work. But now I think we've got something, hopefully that might be a little bit better.
Okay.
Now, what would we put for our first term?
2 cosine
2 cosine
x.
x. Yep. So now we've got that. What about my signs in the parentheses? Positives, negatives, or one of each?
One of each.
Mm-hmm. So you're going to need one of each, and 2 numbers that multiply to give you 1.
Negative 1 and 1.
And 1. Okay, let's check that. That's 2 cosine squared. 2 cosine times 1 is 2 cosine. What's 2 cosine? Take away 1 cosine.
That's cosine?
Just cosine, and that's exactly what was in the middle. So we have factored it correctly. Now, this problem is at the same stage as that problem.
Okay.
You would take each factor
So
and set them equal to 0. So you'd have cosine x equals a half, and cosine x equals negative 1. Well, cosine x equals a half, we've already solved that problem. That was part of the one we did for the first one.
okay.
So we already know the answers are pi over 3 and 5 pi over 3. And this one we have not done yet, but what would you do to get cosine x by itself in that one? Oh, I'm sorry, what would you do to get x by itself in that one?
The inverse of cosine?
Yep. So take the inverse cosine. And if you do the inverse cosine of negative 1, you get 180 degrees, which would be the same as
Pi?
pi. Yep, there we go. So there's our 3 answers. All right, so next we're going to take a look at 8.1, which is on solving right triangles. Oh, no, sorry, solving non-right triangles. And there's 2 laws we learned, law of sines, law of cosines. And just by making your table, we can tell which law this is. Based on our table, do you know what law we're going to use?
Sine?
Yep. What in the table tells you that it's law of sines?
2 angles one side.
Okay, we have 2 angles in one side. How about the placement of where the things are?
Oh, there's one row that's completely open.
Yeah, well, we have one row that's open, but we also have,
One that has an angle next to an empty side.
okay, we have an angle next to an empty side. That's not the one we want to focus on, though, to know its law of sines. It's the middle row,
The middle row because it's full.
because it's full. Yep, so the middle row tells you its law of sines in this case because you have both pieces of information.
Okay. Does it matter? Does it have to be in the middle?
Nope, it could be any row.
So as long as one row is full.
Then it's law of sines.
Okay.
Yep, one row has to be full. All right, so now what could we find first without too much work?
A.
Well, we can find A, but I can think of something else that's going to be a lot less work than A.
C.
Nope, something else.
Gamma.
Gamma. How can we quickly find gamma?
We add the 2 other angles and then we subtract by 180.
Yeah, so what would gamma come out to in this case?
Come on to 4, so 40. That's 6. So we add them both and then we subtract by 180.
Yes.
Sorry.
Oh, you're good.
Negative 110. But
So we don't want to end up with a negative angle in a triangle.
okay, let me reach my head. So we add the two angles, 40 and 30,
Yep.
and then we subtract by 180.
Subtract that from 180.
Oh, subtract that from 180, so that would be 110.
110. Yep. Okay, so now we've got that angle. We still have to find these 2 sides. Which side we do next does not matter. So which side do you want to do next?
Let's do A.
All right, so we're going to find A. So we're going to set up our law of sines. And when we set it up, it always starts out looking like that. And what could I fill in on the left side to help me find A?
On the left side, so
Yep.
for the first one you would put 40,
Okay, so sine of 40 degrees.
and then you put A under it.
All right. And what about on the right side?
You would put sine of 30,
Okay.
and then put 10 on the bottom.
And how do we solve to get A by itself?
Cross multiply.
Cross multiply, yep. So we're going to have A equals, you're going to have 10 sine 40. And then when you cross multiply, you're going to end up having to divide by the sine of 30. And that is your answer for A.
Okay.
So we can type that in. Make sure when you type it in, you are careful with parentheses. Okay, you want to make sure you do it just like I did right there. 10 sine 40 divided by sine 30.
Okay.
And that gives us 12.856. 12.856. All right, that's our first side. Now we got one more side to find, and we're going to find it the same way that we found A.
Okay.
All right, so how would we set it up to find C?
Let me just write this down. Find C. Put signs on both sides.
Okay, so yep, we can just get that ready.
So we have sine 40.
Okay. So you're going to use this top row?
Mm-hmm.
How come?
Wait, would we instead use 110 for it? Since we're looking for C?
Well, yeah, you definitely have to use this row that has C in it, yes.
Or is it better to use the middle row because it has less ugly looking numbers?
So the middle row has nice numbers and they were given.
Mm-hmm.
So
So we always use a given when looking for one?
I would try to use as much given information as you can.
Okay.
Yeah.
Got it. So Alright, so it would be sine 30
Okay.
over 10.
All
And
right.
sine 110 over c.
Yep.
And then we cross multiply.
Yep. We're going to cross multiply the same way. And when you cross multiply, you're going to end up with 10 sine 110 divided by sine of 30. So that's going to give you 18.794.
What do we see?
Okay, and if we look at that, it looks like the biggest angle is with the biggest side. The smallest angle is with the smallest side. And then any two sides added together looks like they are bigger than the third side.
Okay.
So everything looks reasonable.
Can you repeat that one more time?
How we found C?
No, not how we found c, to make sure that everything is correct.
Oh, the biggest side should always match up with the biggest angle. And then any two sides added together always need to be bigger than the third side.
Okay.
Yep.
Thank you.
You're welcome. All right, so we'll try one more, still with law of sines, because we have a full row, but we also have an empty row. We don't have any way to find anything in that row. Whenever we have that empty row and you cannot find anything directly in it, that's the side-side angle case, which means we need to check for 0, 1, or 2 solutions. It also means that we are forced to find something first. What angle do we have to find first?
Beta?
Yep, so we have to find beta. And how would you set up your law of sines to find beta?
You go sine, and then we sine 60
Yep.
over 3.
Okay, and how about on the other side?
On the other side, it would be sine beta
Yep,
over 4.
over 4. Okay, so this time we don't need to cross multiply because we're just trying to get sine beta by itself. So we just really want to get the 4 on the other side. So how would we
Multiply
do that?
4 on both sides.
Yep, just multiply both sides by 4. And now we've got sine beta by itself, but now even more, we want to get just beta, not sine beta.
Inverse of sine.
So yep, take the inverse sine. Those are going to cancel. And now let's type that in and see what we got. So inverse sine, 4 sine 60. Oops. Inverse sine of 4 sine 60 divided by 3. That's how you'd have to type that in.
Okay.
If you type that in and you get a domain error, then that means this is a no solution problem. Let me just double check everything. So yeah, I can confirm this one is a no solution, which means we tried to take the inverse sine of something that is bigger than 1. So there's no solution for beta, which means there's no solution for everything. All right. So there are 2 other cases with that you would want to know for the test: the 1 solution case and the 2 solution case. All right. So that's what we did yesterday. We did some examples of the 2 solution case,
Okay.
but that is definitely important for the test.
Got it.
All right, so the last one we'll take a look at is from 8.2. So this is solving a triangle again. But this time, what's different about our table?
None of them have a full.
Yeah, we don't have a full row anywhere, which means law of sines is out. Can't use it. So we have to use which law to solve?
Law of cosine.
Yep, law of cosines. And whenever you're doing law of cosines, you have to solve for the side you don't know first. So that's the first thing we need to find. That law, or that version of the law, is going to start out b squared. And what comes after the b squared?
B squared equals A squared
All right, let's do that as we go. So a squared
plus C squared.
is 625.
Okay.
And c squared,
C squared would be
1681. And what comes after the a squared plus c squared?
Minus 2ac.
All right, so 2ac. So that's 2 times a times c is 2050. All right, and what else?
And then times cosine. And then it would be beta in this case.
Which is?
Cosine beta.
Yep, and that is how much?
Oh yeah, 125.
125. All right. So now we have some like terms we can combine. What are my like terms on the right side that I can combine together?
6 and 5 and everything except for the cosine 125.
Yep, so 625 plus,
Wait, say that again?
so what are we going to do on the right-hand side next?
Add the 6 and the 5, which is 11. Oh, 625. Oh,
Yeah.
sorry, that's plus. 625 plus 1,680.
Okay, so let's add those up. And that's going to give me, let's see, 2,306. And we'll just copy the rest of that down. Okay, so we combine those together. Now, there's nothing else we can do here without getting a decimal. So all we really want to do is get b alone. And what would we do on both sides that would get b alone?
Find the square root.
Yep. So we're just going to take the square root of everything on the right. And we'll type that in, and that'll be the answer for B.
Okay. 125. 2.
Okay, when we do that, it looks like we're going to get about 59.007. That's what it looks like B comes out to.
Okay. And that is okay.
Okay, so let's at least set up the equation for alpha. I don't think we'll be able to go through solving it, but we can at least get it set up.
Okay.
All right, so whether you do alpha or gamma next, it wouldn't matter. I just picked alpha. And how does the law of cosine start that has alpha in it?
It would be sine.
So it's going to be something like this.
Oh, okay.
top.
Wait, no. So this is the line of cosine. All right. That would be alpha, you said?
Yep.
A squared
All right, so a squared equals,
b squared plus c squared minus 2bc times cosine and then the alpha.
alpha. Okay, so we can fill everything in. So a squared equals
B squared, which would be 59.007.
yeah, 59.007. I know that's rounded, but that's what we're using right now. So b squared and then c squared is 41 squared minus 2 times 59.007 times c times cosine alpha. All right, so now that's the equation that you set up to solve for alpha. So we're going to end up squaring all those, doing that part out. We'll be able to add these two together and bring it to the other side. And then from there, we'll have to kind of keep going to get alpha by itself.
Okay.
All right. So we got through the one where you solve for a side, but then we can maybe, before the test, we could do one where you solve for an angle as well.
Okay.